Hi everybody. Today I am going to discuss about Euler's formula. Euler's formula, it is named after Leonhard Euler, and this formula, it is a mathematical formula in complex analysis that establishes the fundamental relationship between the trigonometric functions and the complex exponential functions. Right hand side, this is trigonometrical functions, and left hand side, it is complex exponential functions. Now in this equation, say e to the power ix equal to cos x plus I sin x. In this formula, e equal to base of the natural logarithms, I imaginary unit, x is equal to angle in radians, and cos and sine are the trigonometric functions, cosine and sine respectively. So this formula is commonly considered for real value of x, but it remains true for all complex values. Very important points. So let's move in the next slide to see how we can prove this formula. So various proofs of formula are possible, but here to prove Euler's formula, we are using power series expansions. So what is the power series expansion? This one, the power series for e to the power x. I mean this one, this series we'll use, but we have to expand it. To expand this series, we have to understand the basic facts about the power of I. So what we will do, say we will write the power series for EIX. It means we are putting I in this series. Here it is X, we are putting IX. So what will be the changes? All the X positions we have to write IX, because we are trying to find the power of I. What are the basic facts behind using this I? So surely here ix square, according to this, as well ix cube, this is 3, then this is 4, 5, 6, 7, 8. This is the series for EIX. So we have to find the value for I square, I cube, I to the power 4, I to the power 5, I to the power 6. So once we find those value, so using those value, surely we can find the real series for EIX. So let's move in the next slide. So this was our EIX series in the previous slide. We brought it here again. Now on this, what you will do? I want to prepare the value for I. Say it is I equal to square root of minus 1. As it is square root of minus 1, so I have to calculate if the power is 1, it will be I. If it is square, it will be minus 1. If it is cube, it will be minus I. In this way, I calculated I5, it is I. I6, it is minus 1. I7, it is minus I. So all this term I have to put in this series. So let's see what it comes. So it appears as this. Because look at I cube. Here I cube means minus I. So I put here minus I x cube by factorial 3. Again, if I look at I7, it is minus I. So I7 minus I. So it will be minus x to the power 7 divided by factorial 7. Look at this. Here is the miracle. We got two groups. What's the two groups? These are the groups. This is one group. This is another group. Look at here. All are odd numbers. This is all are even numbers. This is all are odd numbers. 3, 5, 7. It is odd numbers. This is 2, 4, 6, 8. It is even. Taken from here. So total terms are divided into two parts. One is with even numbers, another is with odd numbers. As well, here I have taken I common because look at here 5, 7, 3 all are having I. So I have to take I as a common for this. Now let's see in the next slide. And these two actually we'll see in the next slide because we can write it as a sin x and cos x. So here I got 2. I brought it. Here this one, it is, we can write it as cos x and this will be sin x. So once I get this cos x, because these two terms are the Maclaurin series for cos x and sin x, very important points. This is Maclaurin series for cos x and sin x. So we put cos x, sin x, and here I imaginary e to the power ix. So e equal to base of natural logarithm. Already we know imaginary unit, angle in radians. So we got the Euler's formula. And that's all for today. Thanks for watching.